Alright. Hey everyone, it is time for another recitation after that long break for build weeks. Today we're going to be doing the Monday challenge, the Node API challenge, which is going to be our first project involving Node and Express. If you want the absolute basics of kind of how Node and Express work, then I'd refer you to a video I made a couple weeks earlier about that. Here we're going to be largely looking at the project and trying to solve that. So over here I have cloned and yarn installed my project, and let's take a look at what we've got here. So our important thing to look at first is this index.js. That's where our project is really going to start off, same as our React index.js. But notice we have nothing here. Unlike React, where we have kind of a lot of stuff going on in order to make our website work, with Node, we're really free to start from nothing. And in fact, most of the projects you'll work with in the coming weeks will literally begin with nothing, and you'll initialize your package.json and the entire project yourself. So we have nothing inside of our index.js. But the README does mention that they have some existing stuff for us as far as database access goes. Inside of this data folder, we have a file called db.js, and everything else in here we can ignore for now, but we're going to learn about each piece of those as we go through. So inside of this db.js, they provide to us these functions: find by ID, insert, update, and remove. And this is going to form the foundation of our API interacting with the database. We do not have to worry about how these functions are implemented. We just need to know how to work with them. So you'll learn how to write these yourself, but these are fairly standard functions when interacting with our database. So now our goal is to write our API. So the first step is going to be to require Express to create our server, which is done by calling the Express function, and then to get our server to listen on some port. So I'm going to do server.listen on, let's do 4444, and I'm just going to console.log a message, server on 4444. There we go. Now, if I look inside of my package.json, we'll see we have these scripts. And when we did a create React app, we already had a bunch of different scripts for us. And we generally start our project with yarn start or npm start. Notice we don't have a script called start here. We just have this one called server. If I try to do yarn start, we're going to see that I get an error. Command start not found. This means I don't have a script called start. What I need to run is yarn server. And this will start up the NodeMon server that was already included in the dependencies. Now notice I get this error, and I actually really like that the projects are structured to give you this error. It says cannot find module express. Inside of my index.js, I'm requiring Express right here, but what this error is telling me is that I don't have that anywhere on my computer. And that's because if we look inside of our package.json, we'll notice we have some dependencies here, and Express isn't one of them. So we have to go ahead and add that to our project. So I'm going to do yarn add Express, and this is only going to take a couple seconds. This is not a React project. We do not have thousands upon thousands of dependencies here. And you can see my package.json is now updated, and I have Express in there. So I should be able to do yarn server, and there we go. My server is listening on port 4444. Now we can start writing our API. So for this project, what they want is for us to implement the following queries: a post, two gets, a delete, and a put. So for our project, we have a database that contains users with user information. and we're going to want to get all of the users, get individual users, add users, delete users, and modify users. So let's start with our GET request, because usually that requires the least from us. We're going to do this by writing a route for our server. So I'm going to do server.get, indicating that I want to add a GET request to some route, which I'm going to do at /API/users. As the second argument to server.get or post or put or delete or whatever, I want to provide a callback function that is going to take two arguments. That is the request object and the response object. Most commonly, we're going to see these abbreviated as rec and res, and that's also what I prefer, so that's what I'm going to be going with here in today's project. So the request object contains all the information that comes in with the user's request, and the response object is the object that allows you to specify your response. When the user comes in and performs a GET request on this route, what we want to do is we want to send a response that contains the user's information. Luckily for us, we already have in our db.js file a function called find, and this is going to return to us all of the users inside of the database. So I'm going to console log, I'm going to import my database file, which I'm going to do with this require syntax. I do the same thing with relative pathing, so it's going to be data/db.js, because I'm at the root. I want to go into the data directory and then grab that db.js file. I'm going to console log the output of db.find, because that's the function that's supposed to find all the users out of my database. And then I'm also just going to end the request so that it doesn't go on forever. And we're going to see this console log inside of our console, where our server is running. Over here, I have Insomnia already set up and ready to make a GET request to my user's endpoint. And we'll see that we get our console log here, but this doesn't look like user information. This looks like a bunch of stuff that I do not fully understand about database things and whatnot. And it is. This is built using Next, which is going to be our query builder to allow us to interact with databases. But we really don't have to understand how any of that works, except for the fact that database queries can take a long time, and also a potentially inconsistent amount of time. So what do we do in JavaScript when we have code that can run for a long time and we can't really predict when it's going to end? We put it in a promise. So this db.find is actually a promise. So if I want to get the users, I do a .then, and then it should give me my user information. So I do db.find and .then, and I try to get my users, and when I make this request, we're going to see this console log is going to present to us this array of user information. And that's exactly what we want. Now we have to return this to the user. In this case, instead of doing a console.log, I'm going to use the response object, which allows me to set a status code, which I'm going to set equal to 200. 200 means good. And then I'm also going to give it some JSON, which is going to be that array of users. And I can remove my res.end, because whenever we send back some JSON here, that is going to end the request. It's going to send the data, so I don't need this anymore. And now, when I send my GET request to the user's endpoint, we're going to see, if we go into this preview here, our user array. All right. Do we have any questions at this point?
Can you, sorry, I somehow missed the db.find part,
Hmm.
because I understand like the res.status and then the chaining the JSON part, but can you explain why in this case we're using db.find and then .then?
Yes, it's because that is what was provided to us in the project. Um, there's a literal database that's already set up that contains the information about Sam and Frodo. And instead of having you write the functions yourself, which will interact with the database to give you that data, or to have some in-memory JavaScript data structures like arrays and objects, um, Luis has provided us with a database as well as some functions set up to go and get information from that database as well as update information inside of that database. So in the README, we see we have this dbjs file inside of the data folder that contains these functions find by ID, insert, update, and remove. And this also contains the information you need to call them. The really important bit is that these all return promises. They're like API requests when we interact with our database. It's something that can take a lot of time, and we don't want our code to stop there. We want the other parts of our server to keep running. So we use promises to execute this code via a callback whenever that database request has finished. And I know in lecture we saw the like dot finds and dot filters and maps and everything to update some array we were holding in memory. Here we actually
Mm-hmm.
have a database set up for us. So.
Got it. So in this simple case where it was just a dot get, because I did this yesterday, but I didn't do that part,
Mm-hmm.
it still returned it when I tested it on Postman or Insomnia. So because it was just a simple one, I'm assuming it still worked, but we want to be able to use these already established.
Yes.
Okay,
Yes.
thank you.
And you'll see if you read ahead, you'll know what these do. But if you look at the functions themselves inside the dbjs file, they're very simple. They're really one-liners to interact with the database. And you're going to be so sick of writing these exact functions after a week or two. Um, but important
Yeah.
thing, they return promises, import them out of the DB file, and we're good to go. All right. Any other questions?
I don't know if I'd really call this a question more than I noticed when he was going in the lecture today, when he's going through all these gets and all that,
Mm-hmm.
that it seems pretty much like boilerplate code. Am I correct in assuming that? I mean,
Some
like,
of some of it's gonna feel pretty consistent and boilerplate. Like writing these get routes is gonna be like, okay, so we're going to retrieve some information from our database and then return it to the user. We're gonna do this and we're gonna do that. Um, the more complicated stuff comes in when users are adding and modifying data from the server, how you choose to architect your API when there's multiple pieces of data that are distinct, like users and books, but users can read books. So, how do you choose to associate that data together? How do you choose to store that in your database? How do you choose to retrieve and display that information to the user? Um, and there's absolutely, work in here that's going to require intelligent decision making. Um, these find functions are not always going to be this simple. Um, for example, um, but for this part right here, yeah, pretty boilerplate. It's day one though. It's day one. Any other questions? Okay, well then I'm going to keep moving. The next endpoint that we want to set up here is going to be getting an individual user object. So I'm going to write another server.get, and this time it's going to be at /API/users/:ID. So when we did React Router, we would use the colon something form in order to specify a URL parameter. And that's exactly what we're doing here. We want to, when the user requests some URL, like /API/users/2, for Express to parse out that 2 from the URL and give that to us. And we call this :id a URL parameter, a param. You also see it called a slug. And we can access that out of our request object, right? This :id is part of the request. So we do that with request.params.id. That is going to contain the ID of the user that is being requested. And notice this feels very similar to how React Router did it. We would do match.params.id. Here we have rec.params.id. Then let's just view this whole thing. I'm just going to put a response.end here, and I'm going to console log rec.params so we can take a look at that. So instead of writing these, you know what, I will do it. New request, get user, localhost 4444 /API/users/1. Oop. I do not know why I did that. /1. So I'm going to send this GET request. It just finishes immediately because I have this res.end here. But you'll see that when we console log the rec.params object, we see an object that has ID and a value of 1. And note that its value is a string. Our URL is just a string. You know, this 1 could be anything, but Express does not know that we want it to be treated as a number. And that's fine because I believe the findById function that was provided to us does convert it into a number. So we don't have to be too concerned about that here. So with this findById, I want to get the user with the ID out of my database and then return it to the person making the request. So I'm going to do that by using my db.findById function, and I'm going to give it an ID as an argument. Then I am going to receive the user object with that ID, and I'm going to return res.status of 200, which means good, and I want to send back some JSON, and that is going to be that user object. So now, when I send this request for the user, I receive the information for Sam, that single user object out of my database. And I can change this to a 2. And now I get Frodo. Perfect. What if I change this to 678? I get nothing, right? Because there is no user with an ID of 678 in my database. But I should probably indicate something different in that case. So what this function findById actually returns in the case where it does not find a user with that ID is undefined. We can verify this by console logging. It's important as we're learning these new things to console log and to look and see what is happening here. So I'm going to make that request again, but now I'm console logging the user object, and we can see that in the case the user is not found, they are undefined. Now if it is undefined, I probably want to send back a different response, and we can do that with just a simple if statement. So if the user exists, then I want to return a status of 200 as well as that user object. But if that user doesn't exist, then I want to return a status code of 404. And we can look up the status codes here, and we can see what the different codes mean. So codes starting with 200, those represent success. These means what you wanted to happen has happened. The main ones here are marked with stars. This is a very good website. I've been to it approximately 1 billion times. 200 means good. 201 means good, and we also created the data that you want. You generally return a 201 on a successful post request. 204 means successful, and I'm not giving you anything back. You'll often see 204s on delete requests because, you know, what do you need back? If you deleted something, it doesn't exist anymore. 400s mean client errors. That means the person making the request has goofed up. So 400 is your generic bad request, and there are some specific ones here. 404 means whatever you were looking for wasn't found. This is the one that we should probably be most familiar with, because when you try to visit something on a website that doesn't exist, you'll often see a 404 page. Then there's also the 500 errors, and that means that the server has made a mistake. So in this case, we want this 404 error. The user has requested a user with the ID that doesn't exist, and the README for this project contains the response that we want to send in this case. So when the user makes a request here and the ID is not found, then we want to send this message. The user with the specified ID does not exist. And for some reason, the keys here, message and error, actually, oh, I remember this, are inconsistent. This is because we can return any JSON object here we want. It's better if it's consistent so the user knows whether to look for the error or message key to find that error, but it's up to you. It's a banana name. I'm going to stick with error here. So I'm going to say error, and then I'm going to return this message. The user with the specified ID does not exist. So now when we go into our Insomnia and make a request for that user that doesn't exist, we get a 404 and our error message, which is perfect. We want to be a little bit more careful about this because right now we just have a .then. And whenever we have a .then, we should also probably have a .catch because something could go wrong inside of the database. And in that case, we want to catch that error and we want to return a 500. So we want to let the person making the request know that we've received it, we've tried to process it, but something went wrong. If we don't do that, the requester is just going to be sitting there waiting for a response forever. So I want to make sure that I catch this error, and I'm going to console log it. This is not strictly necessary, but again, as we're learning things, we're going to want to console log and see what errors show up. This is also good practice in the sense that we're performing logging. So this is called console.log because when you deploy your services, they're going to generate lots of information about what's happening to them. And it's going to make it easier for you to debug issues if you have these logs set up. Because, for example, during your backend build week and you deployed a Heroku and everything looks fine when you deployed it, right? You didn't do anything wrong. And then your front-end people start making requests and saying like, oh, all these endpoints are broken. You can go and inspect the logs, the result of all these console.logs on Heroku. And that's going to allow you to see, okay, this was the correct request they sent it. Oh, it triggered this error in the database, or oh, maybe their stuff is weirdly formatted and that's causing that issue. So logging errors, generally a good idea. Then we also want to send a response. The status code is going to be 500. If our database threw an error, then we goofed up. And I'm going to return some JSON with an error message in here. Let's see, I want the message to be the user information could not be retrieved. So let's do that one. All right. And we should probably have this .catch also on the get for all of the user information. Let's see. Yep, I have an extra semicolon there. And this time it should be the user's information could not be retrieved. And I can't actually trigger a 500 yet because the database is working fine. But my 404 is doing good. My successful requests are doing good. And the 500s there are set up just in case, which is good practice. So do we have any questions here? No? We're feeling okay about that? All right. Let's start doing our more complicated requests. Let's do a post. So right underneath my server.get, I'm going to do a server.post. And I want to do this underneath the first get because they're going to be situated at the exact same endpoint. Here we're getting the users. Here we're posting the users. In this one, we're trying to get a specific user. There are certain operations we do on specific resources, and some we do on the entire set of resources. So if I want to get all the users, we do that at /users. If I want to add a new user, I do that at /users. Generally, we get, delete, and put to a specific user, a specific instance of this resource. So I like to keep my post right next to my first get so that these URLs kind of line up. I'm going to provide my callback, which accepts the request object and the response object. And here, I'm going to console.log the request.body. Because when we set up in Insomnia or Postman the request that contains some JSON body, that's going to be placed on the request.body. Or at least it should. This isn't actually going to work. I want you to see this because you're going to do this constantly. And then I'm also going to pop in my res.end so my request doesn't hang out forever. So I'm going to make a new request. It's going to be post users. It's going to be a post request. We're going to go to localhost 4444/API/users. And our body is going to be JSON. And we have to be careful about this JSON formatting because JSON is not as forgiving as actually writing JavaScript objects inside of JavaScripts. So our keys all have to be wrapped in double quotes. And what does this information look like? So we need a name and a bio is what we're going to be supplying. And then this created, updated at, and this ID, those will all be handled by the server. So name is going to be Henry Blevins. If we want to add another key, we need a comma at the end. And the bio is web21 node TL. Notice I cannot have this trailing comma here. If there is not another key, I cannot have a trailing comma. So it ends right there. Now, when I send this request to my server, this should be console logged because I'm console logging the request body, right? This is the body. So let's send this request and see what happens. Oh, cannot post /API/users. I forgot this opening slash here. That's not the error that we want to see. We want to see this error. When we console log the body, we get undefined. Does anyone know why the body's undefined when I have so clearly defined it here? The reason is because Express by itself does not care to interpret the user body. Notice how when I click here on the different formats the body can be, there's a lot of different stuff here, right? It's multi-part form URL encoded, JSON, XML, EDN. I actually really like EDN. There's all these different formats the request can come in. And if we click on timeline in Insomnia, we can see what our request actually looks like. It's this text here that specifies we're making a post request to this endpoint, various information about us, and this is our request body. And this is literal text. This is just literal strings here. And what Express doesn't do by default is try to interpret what type of string that this is. We have to tell Express to do that, and we do that with middleware. So Like with Redux, we can write functions that are going to go in between Express receiving the request and us processing it. Just like in Redux, we have middleware that goes in between us dispatching some action and then us receiving that action inside of our reducer. So we can write functions that will see the request coming in, check and see if the text being sent along with it is in this JSON format. Notice this line here, content type application/JSON. And if it sees this, then it will parse the body into a JavaScript object and stick that inside the request for us. Now, that sounds complicated. It's already built into Express. We just have to tell it to use it. We say server.use in order to apply some middleware. And we're going to give it the express.json middleware. And we debugged this right at the opening with someone who is having this issue. They did not put these parentheses here. That's not going to do anything. You need these parentheses because you can pass some configuration options in here. We're not going to do that today. I don't think we're really ever going to do that ever. But express.json with the parentheses inside of server.use. Now, when my server has restarted and I send this post request, we see that when we console log the request.body, we see the actual stuff that I had intended for the server to see. So do not forget your JSON middleware. Otherwise, not going to be able to see the JSON. Any questions with that?
So we shouldn't be seeing no body return for response?
No, right now we're seeing no body return for response because I haven't returned anything with my response. I'm just using response.end here to kind of cut it short because I just wanted to console log the request.body. When we specify in previous requests this res.status.json, that's sending back a response body, a body of type JSON.
Thank you.
You're welcome. Any other questions before we actually write this endpoint? Alright, I want to show one other thing, which is what the cool kids do. So in this get, where I did id is equal to rec.params.id, params is an object, so we can also write this with destructuring. Ooh, spooky, can't forget destructuring. Okay, so inside of our post, we want to save this user into some variable, and then we're going to want to use one of our database functions that was given to us. In this case, it's going to be user. Or I'm sorry, it's going to be insert, which accepts a user object and then does some stuff we don't understand yet. So I'm going to call db.insert, and I'm going to give it the user. Then I want to see what the database gave back to me with this operation. I'm just going to console log this something. I'm going to keep my res.end in here. Otherwise, I can show you what happens when I don't respond to anything. It's that Postman will keep waiting and waiting and waiting for a response. That's why I put in this res.end while I'm just kind of debugging. So let me send this request. We see that what I'm getting back here, it's an object that contains the ID of the user that we just added. Right, this was my request body, and then this is the console log from the db.insert. So just like our APIs, our databases can be written, our database queries can be written in any way we so choose. They don't have to return the data that we're necessarily expecting. So commonly when you'll write an insert function, you will write it so that it will return the inserted data. Here it just returns the ID. So we're going to have to figure out how to take that ID and then get the user associated with it. Does anyone know how we can do that? It's going to be with our find by ID function that we had previously used inside of this get. Right? We can give this an ID, and it will find the user with that ID. So what I'm going to do is I am going to take in this this user ID object. We'll call it ID obj. And what I want to do is I want to perform a db.find user, or no, find by ID. And I want to give it the ID as an argument. So this object contains a key called ID, which has the value of the ID of the user that we want to return. So I'm going to do ID object.id. Now this in and of itself is a promise. So I can write my dot then right on the end of it here, but that's going to cause my code to kind of nest and grow increasingly further to the right. So instead, I can put my dot then right here, because this callback here is using the implicit return. So this is returning the result of calling db.findById, and that's going to return a promise. So I can chain another dot then off there. And now I can get my user, and I can return res.status 201, right? 201 is good, and the information had been created. And then I'm going to return as JSON that user object. So I'm going to make my request again, and we're getting some issue. Headers, oh, it's because I have my end in here, and now I am trying to return a different body. So let's try that one more time. There we go. Now it has returned this user object using our findById function. All right, any questions with this? I just realized I have not been checking Slack. I apologize if people have been writing questions in there. Whew. No one has. Okay, so I want to talk about a couple subtle things here that involve how we're handling this. One, this is a stylistic choice. I do not like writing something like ID object here and then doing ID object.id. We know this is going to be an object, and we know it contains a key called ID, and that's the only information we really need from it. So we can use destructuring. That looks so much cleaner to me. When you destructure an argument inside of an arrow function, you have to surround the argument list inside of parentheses, and then you can use your destructuring. So here I am destructuring the first argument as an object, and I'm getting the value of the ID key into a variable called ID, and now I'm passing that to my db.findById. And this works exactly the same. We'll see. I can send that here, and we're good to go. Now, when it comes to error handling, we're chaining these dot thens, and I can very easily put a dot catch on here and get my error and console.log the error, and then return res.status of 500 and a JSON. And I'm not going to keep up with what the README says, because you can do that part yourselves. So we have this server error here. But the way that this dot catch is going to work is if this db.insert throws an error, right? There was an error inserting the user into the database. It's going to get caught by this catch. If retrieving the user from the database after it's been inserted throws an error, it's going to be caught by this catch. So it's probably pretty important that we indicate to the user which point that error occurred in, because they probably want to know, was the user that I gave you created, or do I have to do that again? Or was it created and you just had issues, drumming it up out of the database? Some of you might be thinking, well, what if I move my .catch up here, right after this insert, and say, aha, server error inserting user. Well, you can't really chain .catches and .thens in this manner. This .catch is going to kind of absorb whatever result that the insert is producing. And you can write .thens after it, but this isn't going to return anything in the case that it did not catch an error. So we also can't write it like this. This would work. This would catch any errors in inserting the user, but this .then, which requires the user from this promise, the db.findById, it's not going to see that. So this is actually the argument for actually nesting our promises rather than continuing to do a .then chain, because this will allow us to put our .then directly onto our db.findById, and then we can throw a .catch onto here. And let me do some housekeeping in order to format this a bit nicer. So we do our db.findById, and then we do our .then and our .catch, which I'm going to copy and paste this one because I'm lazy. And then now we have error retrieving user. Did I spell that right? I did not. Okay. Okay, so now our user can tell where exactly the error occurred inside of this chain of events. Did it occur when we were inserting the user? Did it occur when we were retrieving that user? We could also put some conditional logic in here. We could inspect something about this error object and tell, which place triggered it, but this is going to read a little bit easier. I know it looks kind of funky as we've nested it here. Some of you, we will learn the async await syntax, and some of you may prefer that as well, but it's ultimately going to be pretty similar to this. All right. Any questions here?
Yeah, I'm a little bit confused on the double thens. When on that const user equals rect body, couldn't you do something like const, I don't know, const, what are those two parameters I'm thinking of? Not the ID, but hold on a second. I'm trying to think.
It's the name
and bio. That's what I'm thinking of.
Yeah, I absolutely.
And destructure the name and bio instead.
Yes.
Equals rect body. And wouldn't that get rid of the other .then?
No, because that's not what the purpose of this .then is. This second .then is to find the user out of our database so that we can return it, because that's going to contain some additional info, right? All I sent was this name and bio, and the server returns back to me an object that contains an ID and also this other information, this derived information, when it was created and when it was last updated. So I need to, after creating this user, after inserting them into the database, find that user from my database and then return it to there. So I use the same name for this variable user here as what I'm getting from findById. That'll work out because of the way that scoping works in JavaScript, but this user object is very different than the one from the request. Because the one that we're getting from findById contains this additional information. So you have a good point, though, about performing this destructuring, because watch as I add another thing here. Let's call it bad key. and then it's going to have a value of something. When I send this post request, I'm actually able to trigger one of our 500 errors, right? And we can see that this happened at the insertion stage because of how I structured my .catches. So we can see there's an error inserting the user. And because I had the foresight to console log the error, we can see that it's this database error, and we may not understand entirely what it means, but we can get the gist of it. Table users has no column named bad key. So what that's basically trying to tell me is I'm trying to insert a user into my database with more information than the database expects. It doesn't expect to see this bad key here. Now, we could do something like check to see that this user only contains the name and the bio, and then return a 400 perhaps, which is the error when the client sends a malformed request, and tell them that they need to include only the name and the bio. We could also perform that destructuring ourselves, so we could get the name and the bio from the rec.body object, and then insert an object containing the name and the bio. So now extra keys are not going to give us this error. Now when I send this, we're not going to receive that error because bad key essentially gets ignored. And that's one of the design decisions you'll have to make when writing your API. Is it better for us to tell the user of our API that they're technically sending an incorrectly formatted request even though we're capable of processing it? We may also want to check and see that both of these things are here, because let me remove bad key, and then let me also remove bio. So now the bio is null. This user doesn't have a bio because there wasn't any in my request body. Well, what if I really want there to be a bio for every user? Well, one, you would enforce that at the database level, as we'll see, but two, we can put some if statement in here. If the name and the bio both exist, then we want to do our whole db.insert thing. We can also rewrite this in a way that's going to result in a little less code. We can say if, oh, that jumped around a bit, if not name or not bio, right? If either of these don't exist, then I want to send back a response with a status code of 400 and a message that says requires name and bio. So now when I try to send this request without the bio, I get an error here. Requires name and bio. You can see how this starts to grow a little bit beyond boilerplate as you kind of have to make the decisions on how to handle these things. And there's many styles in which we could write this too, some of which you'll like, some of which you won't like. But this is our basic post request. We get in some information here, we perform validation on the information, we insert and retrieve that information from our database, we give it to the user, we give them an error if one happens to come up. So any questions here?
I do have another one.
Mm-hmm.
Let's say the find by ID, the insert, and all that. Now that was written by our instructor, correct?
Mm-hmm.
But is there a defined list of those? I mean, is that something that's just being made up for this particular REST API, or is there an actual list of functions like that?
So these are being defined for us inside of the file data/db.js as outlined in the README, and it's these functions: find by ID, insert, update, and remove. And this is a fairly standard list of functions you would want to interact with our database. They're by no means, default. They don't come with anything. Luis did in fact write these. You can check the commit history to verify that. But you can see they're pretty simple short functions. Like this one just returns the database table of users. Find by ID finds where the ID is equal to the ID it was given as an argument. Insert inserts the user into the database. You'll learn how to write these when we learn about SQL and Next.js, but you're going to be writing these functions or copy and pasting them from past projects into most of the APIs that you write and modifying them as they are needed. Like I, for example, like to move this kind of find by ID thing into my insert function. Because generally, if I'm inserting a thing, I want the information that's resultant for that, so I might as well do it inside this insert function instead of inside my endpoints. But again, decisions that you gotta make.
Thank you.
Welcome. Any other questions here? Okay. Let's round out our endpoints. So now we're going to move on to the .delete. I like to group that with the endpoints that end in our :ID here, right? The ones that occur on specific resources. So I'm going to do a server.delete, and this is going to be at /API/users/:ID. We're going to take in a request object and a response object, and then we're going to do our stuff. So we have another one of our supplied database functions, this one, remove. And it takes in an ID, and it is going to try to remove a user from the database. So let's do that. So we're going to do db.remove, or let's save our ID into a variable. I like to use destructuring. So we're going to get that out of rex.param. We're going to call it db.remove, give it our ID, which this function is kind enough to parse it into a number. Another decision we have to make, do we want to do that in the endpoint or at our kind of database function level? Then, if this is successful, I don't care about any information that is coming back from this .remove. I am just going to return a response with a status code of 204. Which means whatever you wanted to do was successful, and I have no data for you. So then I put a .end on here, right? Don't need a message, don't need any JSON. We deleted them, that's good enough. And then let's put a .catch on here. So we'll get our error. We will console.log the error. And then we'll return a status code of 500 and some JSON that contains some error message specified in the README. That is not server error deleting, but it's close enough. I'm going to make a new request here, delete user, and it's going to be a delete request. It's going to be a localhost 4444/users/ let's do 4. I created like 12 different Henry users. So let's try and delete this one. Oh, this is going to be at API/users/4. There we go, 204, no content. But now, if I get all of my users, we're going to see that we have users 1, 2, 3, and then we skipped a 5. I deleted the 4th user. Now, what happens if I try to delete a user that doesn't exist? We get a 204, right? Which is misleading because we didn't actually do the thing that we wanted to do. So let's take a look at what the .then, what our remove is returning to us, and see if that can help us puzzle out what is happening here. So this method, .remove, is going to give us something. Let's console log this something and see what it is. So let's go down here. When I send this request, we see that something is 0 on this user that didn't exist. Now let's try to delete one that does exist. So the 5th user. We now see that it gives us 1. And if I delete the 6th user, we'll see that it gives us 1 again. And what that is actually telling us is the number of things that were deleted, right? Because the way that this is implemented is this is essentially saying delete all users where the ID is equal to some number. Now, IDs are unique, but what if we had said, delete all users where the name is Henry Blevins? Then that would have deleted, like, I don't know, eight users from our database. And so we can use this 0 or 1 as basically a Boolean to tell us whether our delete operation was successful, because 0 is falsy, and any number that is not 0 is truthy. So we have access to essentially this Boolean deleted. So if deleted was successful, we want to send the 204. Otherwise, if deleted was unsuccessful, if we deleted 0 rows, then I can send back a status of 404 and a JSON with an error message, user with ID does not exist. So then now, when I try to delete some random user, we're going to get 404 because that didn't actually perform a delete operation. We also could have done a find by ID to check if the user existed before we had done a deletion, but this way works, pretty much just as well, but with only one round trip to our database. So, yeah. Any questions on the delete route?
Yeah, Henry, I had a question. So how do you know that if it returns more than 1? Like, how did you know, like, it returns, if you delete 2 users, it's going to return a 2? Was there something that you tested to see that?
I did not hear. That just comes from my knowledge of working with Nex. We can look up the documentation for it and see that that is the case, but that's why it's returning 0 and 1 rather than something like true or false, because the delete operation is just going to delete as much stuff as matches the information that you gave it. I mean, I can remove this .where and we can delete all the users, and that should return a higher number. Let's see how that goes. I'm going to have to reseed the database, but let's do that. Oh, I didn't console log it. Oh, no. Okay, let me reseed the database real fast. npx next. Okay, you'll learn what I just did there in a minute. Okay, so I removed this where, so we're going to delete all the users in the database, which is just going to be 2. And now I'm going to console log deleted. Aha, it returns 2 because we deleted Frodo and Samwise, our 2 initial users from the database. And if I try to get the users, we'll see that none exist anymore because I've deleted them all. So you'll learn more about that when we get to the SQL end of things. Let me get those users back in there, and we'll start the server up, and we can see there is Samwise and Frodo back with us. So that's our delete. Any questions here? Oh shoot, I forgot to fix it. All right, we feel good about that delete.
Well, I got one thing that you got the DB remove ID, and he talked about lazy programmers and I guess I'm one of them. I like to write as less code as possible.
Mm-hmm.
Could you get rid of that const?
Oh yes.
And just put DB remove rect.params? Would that do the same thing?
Yeah. And there's value in being lazy. I wouldn't really count this as laziness. The idea is to reduce repetition. So a lazy programmer would be someone who would see this pattern of the insertion requiring us to immediately go and find that user and say, I might want to do this more than once, right? I want to put this inside of my .insert function because that's inherently tied together, right? I insert this user and now I want to go and get that new information. That's almost always what I'm going to want to do. And so putting that code in here in the more reusable place is going to allow us to be lazier. We don't have to rewrite that code ever again. Using this destructuring here, yes, it is slightly more code, but it really isn't all that extra work aside from a small amount of typing. I also prefer it because this increases the explicitness of our code. It's the same reason that I like destructuring props inside of React, is that I can look at the first line of this function here and tell exactly what information it expects from the user's request, right? We need this ID. Whereas if I put it right here, yes, it's still on the first line, but I might need to use this somewhere else, and then it can get a bit clowny for me. So this really allows me to be lazy because I have to check over less code when I come back here in the future. In the same way that inside of our insert, we're destructuring name and bio here. I could have used, rec.body.name and rec.body.bio, but then I'd have to repeat myself here, and it's not immediately clear to me what this endpoint expects from the user. So yes, it would work in both cases. I encourage you to be lazy, but I encourage that laziness to not come at the expense of the readability of your code, because you're going to spend more time reading code than you do writing code. Almost most of your time, actually.
Thank you. That made perfect sense.
Okay, great. All right, anything else before we do our put request and then finish this project up? Okay, so let's do our server.put, same URL /API users :ID, accept our request and response objects. And now we're going to copy and paste some stuff. And this is, I've been using terms like developer senses should be tingling here. Actually, we don't really have to copy and paste that much. We only need to do this. So let's get our name and our bio. The idea here is I was going to talk about, we're going to have to do a small amount of validation on this input. This is something we'll see later on that you could use middleware for, right? Middleware sits in between receiving the request and our endpoints processing it. So you could add middleware to these to check, if the user information is formatted correctly. And I'm not really doing that too much here. On the insert, I'm just checking to see that the name and bio exist. I'm not checking to see if they're strings. I'm not checking to see if they actually contain information. I'm not checking to see if the length is in between different things. And this is generally what we want in a robust API, right? It's nice when we're writing forms on the front end that we, check and see if the information is valid before the user sends it off. But the buck stops with the back end, right? Front end validation is like doors that have a lock in it, that if you poke the paperclip through that little hole in the other side, it'll unlock the door, right? It's not really security, it's more convenience so that you don't walk in on someone in the shower. But the back end does need to be secure, right? The back end needs the deadbolt. You are the final defense before we hit the database. So that is your job on the back end, is to do rigorous input validation. But I'm not doing that here because doing rigorous input validation is hard. Okay, so we're going to get a name and a bio, and I'm going to write a slightly different if statement. Because, like Luis talked about in lecture today, there's technically another REST verb called patch that put is supposed to be for doing a complete update of something, and patch would be used for a partial update. Most of the time we just use put to mean both. You'll encounter patch maybe some places, maybe not, but we're just going to use put to represent essentially all of those operations here. So what I want to check is that we have at least something to change. So if we don't have a name and we don't have a bio, this is where I want to send my 400 status with JSON and some error saying, you know, requires some changes. And this is not the error message that you're supposed to send, and nor is this a very good error message, but that's what we're dealing with today. Okay, so now I can write my actual database updating things. So we have our final function here, update. This is going to take in the ID of the user that we want to update, as well as the object containing the changes we would like to make to that user. So I'm going to have to destructure the ID as well. rec.params, and you can see, you know, now as my code gets more complicated, I can see right here, I need the ID from the URL, the name and the bio from the body, and now I can do my db.update. It's going to take in the ID as the first argument, and then an object containing the user and the bio, the name and the bio. I'm actually curious to see how the database is going to handle doing this if these things don't exist. Well, we'll see. We'll see how this works. Let's charge on ahead. And so then we'll see what the response is. I'll console.log the something. And then I'll put a catch on here, get my error. Console.log my error, and then return res.status 500 JSON error updating user. All right, now let's see what happens. Let's add another request. Put user. So it's going to be localhost 4444/API/users/2. Let's give it a body, and I want to update the name of Frodo to be Frodo the 9 Fingers. It's because Frodo only has 9 fingers. Sorry, spoilers for everyone. And our keys need to be wrapped in double quotes, and this should be a put request. So we send that here, and notice I didn't put a res.end anywhere, so our request keeps running, but we see that our something that we get back from our update is a number again, right? This is going to be the number of records, the number of rows that were updated when we perform this operation, just like our delete. In this case, we can use this essentially as a Boolean, so I'm going to call it updated, and I'm going to write my if-else stuff with this. So if we have updated, then I'm going to want to find the user and display that information. Otherwise, I'm going to want to give my 404. res.status 404, oops, .json, error, user with ID not found, whatever it said in the README, use that. You should spend a lot of time writing good error messages. For example, we could make this a template string. You know, user with ID not found. Ooh, now we're getting fancy. Good error messages mean good APIs, right? Documentation is the most important thing, and error messages are a part of that documentation. Okay, so if we have updated, then I want to go ahead and find that user. So I'm going to do db.findByID, and we're going to give it the ID that we had gotten out of the request params. Then I'm going to get that user, and I'm going to return the res.status 200.json with that user in there. Put a .catch error, console.log, that error, and we'll do a res.status of 500 JSON error retrieving user. And I definitely spelled that wrong again. No, I got it right. Boom, I'm a genius. Notice that I don't have to check and see if this user exists while we're doing it here. Technically, you know, if the user could have gotten deleted right underneath us in between us updating him and retrieving him, but I'm not going to worry about that here. So, yeah, I'm just not. We know he exists. We know that Frodo exists because updated is 1, right? We updated a single record. If that user didn't exist, then we'd get a 400 here. Technically, belt and suspenders, we could check that they exist again here, but I'm going to keep our code a little bit simpler. And now let's see if this worked. So let me send this put request. Aha, there we go. Now we see we just updated the name and it left our bio alone. And there we have our partial update. And I can also update both of them at the same time. Bio, a really okay friend to Sam. I don't know. The lembas bread thing always bothered me about Frodo. Right? You really think Sam would steal all the food? Ridiculous. Frodo the short. Okay, and now we see that that these have been updated here. And if I send none of them, yay, we get my validation that we require some changes. Okay, any questions with our put? All right. Anything else before we wrap this up here? Okay. Well, then thank you all so much for coming. Glad we could get back to these after kind of the busyness that was last week. I apologize for any Java people who joined. I am sticking with the Node track because, unfortunately, I do not know Java well enough to be able to make these videos without any preparation. So, only going to be doing Node videos from here on out. But thank you all so much for coming, and I will see you tomorrow.